Recording started.
Hi Bio30 students. Yesterday we covered a number of topics in our recording, in our whiteboard session, and we just had a few more things that we needed to wrap up from our last session. So I'm just going to cover those at this point in time, and then I'll send you out the recording for it. So as you can see, we've just finished talking about the all or none principle, and we're now moving to just getting a little bit more into detail about neurotransmitters. We talked about them yesterday, and how neurotransmitters are chemicals. Like their name suggests, they transmit information, and what they're doing is they're helping to send messages from one cell to another, especially from one nerve cell to another is what we've been looking at recently. So acetylcholine is a really important neurotransmitter. If you lack this neurotransmitter, you might have some sort of nervous system disorder, some sort of brain disorder. And so it's one of the most common neurotransmitters in the central nervous system. So let's go on to the next page and see how this plays out. Okay, we're not going to be talking about it any further at this point, actually. But just remember, again, that these neurotransmitters, these chemical messages, are sent into the gaps that exist between two neurons or nerve cells. And again, the gaps, another name for a gap between nerve cells is a synapse. So at this point, we're going to look a little bit more in depth into the brain, and just going to highlight a few important areas of the brain. Just get my little pointer here. So the medulla oblongata is a really important area. As you can see, it controls the rate of breathing and also our heart rate, as well as certain other autonomic body functions such as dilation and constriction of blood vessels, coughing, swallowing, and vomiting. Now you see the word autonomic there. When you see that word, it almost looks like the word automatic. And so it's actually good to make that association between those two words, autonomic and automatic. Because these types of things, like the rate of our breathing, our blood vessels either dilating or constricting, things like that, they're things that we don't want to have to think about. We want our bodies to be able to just do them continuously, right? And so again, that's why we're making the connection here between automatic and autonomic. Those are all part of the autonomic nervous system. Okay, just briefly looking at the cerebral cortex, this front area of the brain here, if you think of the crust, think of C for crust and C for cerebral as well, and that'll help you remember that this is the outer region of the brain. This is where most of the brain activity is taking place, within the cerebral cortex. So if you're considering most of the thinking that's taking place in your brain, it would be in the cerebral cortex. Okay, on to the next page. So we've got a few questions here, and I'm going to give you just a few moments to look, to think about them on your own after I ask you them. So first of all, the part of the brain that is directly responsible for the recall of previously learned words. That's our first question that we have here. Do you think that would be the cerebrum, the cerebellum, the pituitary gland, or the medulla oblongata? Previously learned words. Okay, that one would be the cerebrum, and again, that has to do with most of the thinking, the cognitive processes that take place in the brain. Second question then, the part of the brain that controls the unconscious rate, sorry, I just had something pop up there. The unconscious rate of breathing is it the cerebrum, A, cerebellum, B, pituitary gland, C, or the medulla oblongata? This one would be the medulla oblongata, and as we looked at before, it's part of the autonomic nervous system, which we associate with automatic. And again, breathing is something that's unconscious or automatic. Now we're going to look at the fact that the cerebrum is broken into 4 major lobes or areas. And these are the occipital lobe, the temporal lobe, the frontal lobe, and the parietal lobe. And so we're going to look at what each of the major functions is of each of these lobes. So here you can see where they are. You can see the frontal lobe is in the front, and the occipital lobe is in the back. Parietal lobe is kind of in between, and the temporal lobe is below the frontal lobe. Okay, so what do each of these areas of the brain accomplish for us? Well, the occipital lobe has to do with processing sensory information from the eyes. Okay, so remember, occipital eyes. The temporal lobe has to do with information from our ears. And the frontal lobe, very important area. If we could say that one area is more important, it controls things like voluntary movements, speech, personality, and intelligence. So the frontal lobe is very important. The parietal lobe controls sensory information from the skin, as well as processing information about body position. Okay, so our next question says, list the 4 regions of the cerebral cortex and state the function of each. So try, if you can, not to look at the answers first of all, and see if you're able to list what they are. Then have a look at the answers up above. Just refresh your mind. And then I'll just go over the answers briefly. Okay, so again, occipital has to do with information from the eyes. Temporal has to do with information from the ears. Frontal has to do with a number of different things, some important areas of concern such as intelligence, personality, speech. Parietal has to do with sensory information from the skin as well as information about our body's position. So let's go to the next page. The question says, if an eagle's brain were similar in structure to a human brain, impulses that begin in the retina of the eagle's eye would travel first to the, is it frontal lobe, parietal lobe, occipital lobe, or temporal lobe? Well, remember, the eye has to do with the occipital lobe, so the answer would be C for this one. Okay, now we're going to look at a reflex arc. And reflex arcs are interesting because rather than the information going to our brain, the information is just going to our spinal cord. And then it comes back to us before, we have movement after something happens without even going to our brain. So the reflex arc is going to involve 5 different areas. And so let's look at them and see how they kind of fit together. So first of all, we have a stimulus. This example here is a doctor using one of those little kind of hammers to hammer on the area below our knee to find out how healthy our reflexes are. So that's a stimulus. Remember, a stimulus is always connected to a response. A stimulus is something that's taking place in the environment that our senses are sensing, and then our body's responding to it. So stimulus and response are always connected together. So we start off with a stimulus, and then our sensory neurons are going to be firing. And so we have 2 S's in a row. And again, our sensory neurons are picking up information and then sending it to either the spinal cord or to the brain. So in this situation, they're sending the information to the spinal cord. And in the spinal cord, we have interneurons. And then after it goes from the interneuron, it goes to the motor neuron. Because what do we want to happen? Well, when the doctors hit our knee area with the hammer, we want to see our knee kicking forward, as you can see in this diagram. And it's a motor neuron that's going to cause our knee to kick forward. So again, we have the sensor neuron, and then the interneuron and the motor neuron. And you might remember from yesterday that the interneurons connect other neurons together. So that's what we're seeing here. And so then the motor neuron causes a response, which is the leg kicking forward. So those are the 5 parts of a reflex arc. And so I just made a note here that what's interesting is you get a response happening before the message comes back from the brain telling you that it's happened. It's like if you have your hand on a stove. You move it off the stove so quickly because of your reflex arc happening, and then later on your brain says, hey, that was hot. But before the brain even registers with that message that says it was hot, you've already moved it off the stove. And so again, the reflex steps going on are the sensory neuron passing the message on to the spinal cord instead of the brain, and then the motor neuron is fired. All right, so name the essential components of a reflex arc. Well, again, we know that we started with the stimulus. We went on to the sensory neuron, which passed the message to the interneuron, and then the motor neuron. Again, interneurons always connecting two different types of neurons. And then the motor neuron caused a response to take place. So those are the 5 parts of a reflex arc. And the last point I just wanted to make to you guys is we looked at a number of different spinal cord injuries. It's important to know those, but some of the most important ones I could say would be knowing the difference between quadriplegia and paraplegia. And so if quadriplegia is taking place, then all 4 limbs of a person will not be able to be used. Whereas with paraplegia, it's only the lower half of the body that's been affected. And again, quad means 4, so again, you can see why it would mean 4 limbs. So guys, that's all we have for this session. And again, just a reminder that we have our first test coming up next Thursday. I sent out an email about 3 things that you should focus on for this test. After that test, again, the tests are going to be coming more frequently. So I just wanted to encourage you guys to keep up the hard work, and hope you have a great weekend. Take care.